Hi again, I am Javier Orozco. I am introducing all the contents for the built environment sub-module within the overall physical transition module in the Essence course for sustainable smart new cities. Okay, let's make a very quick and rough analysis of what you will see on this sub-module. First, we will go from the different architectural subsystems and the specific limitations that introduce for us into solutions or building typology, which could be analyzed as incipient modules for the system, introducing possible solutions for the built environment through passive systems, and also functional integration, because the future sustainability has to do a lot with the integration of different functions on different parts of the system. The structural sustainability will be considered independently because it's a very difficult constraint which has to meet different rules which should be considered individually in order to perform a feasible city that integrates the ideals of beauty, aesthetics, architecture in one word, and provide the basis for the growth of future smart sustainable cities. Let's go into the details. First, which architectural subsystem? From the past, we consider only the post and lintel, which is beams, which are placed horizontally, and different order styles, which are the design principles for the columns. So our system are columns and beams. This is the basic design for the structure, which is again enriched through the arch bolts and domes, which provide solutions for closing our building, our structure for the future. Again, if you remember, we had the different subsystems: foundation, which is the basis, the place; the structure, which we will develop in detail later; the skeleton, the enclosure or envelope, which is the skin of the building; the divisions, walls, which is the distribution; giving support for services, all the different facilities and the different things or furniture solution. These subsystems were also introduced before, but their constraints are to be considered now all one with the next in order to provide solutions for the built environment. Again, the different building typologies, for example, the concrete buildings, the wood buildings, the steel buildings, when integrating all the different solutions, perform different footprints, which are the solution we should be seeking for the sustainable building. For example, concrete buildings have an initial embodied energy, which is very important, but the construction levels is also important. So concrete is not the solution for future sustainable building, although it is what is used, is what we know best. So the future should try to include other materials. For example, wood, apart from being renewable, it has a very nice and tender and thin footprints, and steel is much better for construction, for the actual embodied energy we introduce in the building during construction, although the cost for use is very, very important for use. For obtaining the material is very important. But this can be diminished in the case that you are reusing this material through a modular approach on the building. Again, when we consider working transportation and all the different elements on construction, concrete is the worst solution, and wood and steel are more or less equivalent. For the initial embodied greenhouse gases, all in all, again, steel, wood, and for the actual construction energy, which is the equivalent to this one. As we can see, the impact during construction for the built environment when selecting the material is very, very much influenced on which solution we are taking. Let's move forward. Apart from that, we have different actual solutions, shapes for the materials, which are to be considered in how we can support these shapes, these spaces, these 3D designs of the building. Let's take the worst example, which is what we can find in the building in Bilbao for the museum. Again, here the importance was to have something which is outstanding in principle, but the use of titanium and the strange shapes really are the worst possible solution for sustainability. If we go into the Gulf countries, we have these two buildings, typically this hotel, which is including nicer solutions in a way, although it's using concrete and it's using a skyscraper solution, which is in most of the cases not the best possible alternative. On the back of it, they're using textiles for providing some renewable air, some flow of the air through the building, which is very nice for the overall ventilation and climate conditioning of the building. The last solution I want to point out is what we find in the Reichstag, redesigned by Sir Norman Foster. The use of these mirrors on the roof of the building is providing light to all the house, to all the different main halls within the building without any cost. And apart from being nice, apart from being architecturally a very good solution, it provides its functional integration with the lighting, which is saved. Let's go into some other solution for our building, the passive system. Basically, they have to deal with thermal comfort, and first we should know what's thermal comfort, the typical temperature, the typical humidity, and the typical attitude we have within the building. If we're working on a table without moving at all, the thermal comfort levels are quite different to those when we are working and moving. The body is creating a lot of heat, and that has to be considered for our thermal comfort levels. If we consider other options, for example, thermodynamics, actual atmospheric outside condition, temperature, humidity, comfort, air quality, humidity, wall temperatures, and how we can interact through all these, we have a puzzle that we are providing solutions with, as you can see, small mirrors, ventilations, natural evacuations of heat, which is the basis for passive systems and obtaining a very good solution without actually any cost. Again, what should we consider as the basis for this design? First, the number of windows, their insulation and avoiding cold breaches in them, calculating the U value, the isolation of the different parts, air tightness, because we should be controlling the renovation of air, the orientation, a solar analysis on the energy, having a strategy for that, thermal mass for being able to mitigate the outside evolution of temperature and humidity, and also some other solutions like passive cooling or natural ventilation, which simply by connecting north-south faces is providing a natural refrigeration which can meet very closely our demands on comfort. Again, there are some other possibilities like subsoil heat exchangers, heat recovery, or even the actual shape of the building that can provide solutions through this passive design of the house. Again, here you have some examples are to develop, and basically this is the result. Depending on how we design our building, we can see on the infrared images the solution and the loss of energy, which is the most important part when we have to run a building and even considering the construction phase. Again, you can have here links to important information solutions on how to implement all these passive strategies for our buildings. Again, move on. Functional integration. Let's take into consideration the stakeholder analysis. Who is the owner? What has the role, the prime necessity of the building? How do we select through, beginning with the architect, the different team of professionals who should be doing this functional integration? We should consider all the team of designers, the general contractors, even the authorities, inspectors, and provide a complete thorough analysis on how we solve with the building all these demands, constraints, and problems. Again, what are those constraints which have to be met? First, the physical limitation, land area available, building soil strength, material performance, or even contractual or laws. Different committees are providing restraints, constraints for our building. The material selection is done not only by the designer and architect, but also from the availability of materials of providers in our zone. The budget, one way or another, is one of the most important constraints for the building. And these ordinances that we spoke about, even at material selection level, but again, the codes and zoning ordinances when considered at building level. These are the key elements for our equation and for solving the final sustainability of the building. Let's consider independently the structural sustainability. Through loads and the different sub-elements, we're distributing these external loads to the basements, to the foundations of the buildings. Again, for being able to obtain structural sustainability, we should meet all the needs of present and future generations, because the lifespan of a building is very long, over 50 years, and we have to consider things like the energy efficiency, thermal bridges, for example, reuse of the structure once it has met its living life, efficient land use, renewable products, protect soil, reduce pollution, and then construct the final life cycle analysis for the sustainability, which is our desired output. The feasible city will satisfy the requirements for these functional performances, give the desired aesthetic qualities and solutions, should not be constrained by legal codes or demands, because the codes should be following what is needed on the building. But again, this is something we cannot control. Of course, it has to be economical and use materials which are close to us, least damaging to the environment, has very little impact, and can of course be reused in a modular way, which is the best sustainability we can have for buildings once they have finished their living lives. All these elements should be analyzed and studied through data structures, including on the different representations and libraries, through the BIM analysis that was introduced in a different module. Again, buildings are buildings, and architects should follow the first design principles have not changed since Roman times. Utilitas, we should solve the need to certain activities. Firmitas, that's something that is durable, and also venustas, also consider that it should be elevated and it should provide a gratifying way of performing our daily tasks. These space design, scale, weight, mass, and basic design elements are met through materials. So the architectural design is including all this in the built environment, and again, they should be considered as constraints which are evaluated in our final performance analysis on the BIM model for the building. Once we have the individual level of a building, we can go up for urban design planning and include them in the city model that can be simplified but should provide enough parameters for the redesign and for calculating the overall impact of our sustainable solution. The strategy, the integration of businesses and functional activities, and the application of all these will provide us with the final city planning, which is the overall conclusion of the built environment approach. Remember, functional classification helps us in applying known solutions at city level for all these needs, and distributing them at city level for providing, for example, transport solutions which are sustainable and for meeting all these constraints, but at urbanistic level. Again, once we have considered all these elements, we will have done a very careful and adequate built environment design. Thank you very much.